I'm probably gonna start at 9 with the second years. Yeah, but we'll see. So welcome to today's tutorial. We'll be continuing with the good question paper. So let me open the other files. So we're dealing with the pathogen problem, right? So it's about pathogens. So let's create the functions, right? Okay, I need to open the question paper. Let me close this. Question paper, where are you? Okay, it's here. Paper B. Okay. So question paper was based on we're doing a simulation, right? So let's start with initialization, which is phase one, right? So with phase one, we need to get the rows, columns, and the number of initial detectors from the user in order to initialize or create our game. So since we need those things in order to create the game or to create our world or our game world, so we're gonna call, since we're creating our game world, I'm gonna call the function create world. You don't have to write it in full and say create game world. You don't have to do that. That's why we simply just call it game world, create world. But it's fine. I'll just write it in full only this time around. And it's supposed to return something, right? Because remember the structure of a function. You put in a return type followed by a space, followed by the name of the function, followed by round brackets, and then inside here you put in the parameters, right? And then semicolon. This is how you define a function prototype, which basically means that this is like a promise to tell C++ that, listen, I will implement this function later on. This is how the function looks. It should return this thing or this type, and it should be of this name, and it should have these parameters. Parameters are actually called inputs. Parameters are what we call inputs to this function. What it returns, right? The return type or what it gives you back, we call that the output, right? And then what it does, right? Basically the implementation of the function. We call that the process. So implementation, we call that the process. So basically, if you still remember in high school, they taught us IPO, right? Which stands for input. You get input and then you pass it and then you process it. And then it gives you back some output. Just like, for example, when you are building products, I agree they use raw materials, which would be basically inputs. I think this thing about raw materials, it was taught in accounting or economics, something like that. Yeah, or EMS. Yeah, I think it's EMS, right? Yeah. Economic management skills, something like that. Hey, taking me far. I did like high school a very long time ago. So it basically uses this process. That's what a function does. It gets input, it processes the input, basically does some calculations or whatever, and then you get a finished product, which is basically the output. So if you had some commerce module subjects in high school, you should know. So let's pass in the information, right? We need to pass in our what is this? Our rows and columns because those are the inputs. Basically, these are the values that we need in order to create our game world. We need our size, which is the rows and columns. We also need the number of detectors. So we're gonna pass those. So int rows, int calls. It's up to you in what order you pass it in, but I usually pass it in the order it's written in the question paper. They started with the rows, then columns, and then number of detectors. So I'm going to pass it in that exact same order. So int number of detectors, right? But then all these parameters, right? All these inputs, the rows, columns, all these things. If you leave it like this, right? Remember this is like declaring a variable. And a variable is called a variable because it varies or it's able to vary, meaning it's able to change. But these inputs, they shouldn't change. So we're gonna actually have to say const int. That would be the most correct way of doing that. So const int and then const int. Okay, let me switch off my data because I'll keep on getting notifications on the phone. Okay, so const int, right? Because we're not going to change them. But it's still not 100% correct, right? What's missing is actually to use pass by reference. Remember when you talked about pass by reference when you're doing functions? Pass by reference, remember it passes the address, the reference of where that thing is. So basically, it actually doesn't use a lot of memory because you don't actually create how do I put it? You don't actually allocate memory for that thing, for that variable. You simply give it a different name. Remember when you talked about, you need to go and revise that session. Go look at that session again. We talked about references or pointers and arrays, all those things, right? And then we also got to talk about pass by reference. So pass by reference, it basically when you put that address, right? So basically you have to do this. Pass by reference. Pass by reference, it saves memory, right? Meaning you don't have to use a lot of space. So that means you basically give that variable a different name. So it's going to be called calls. Meaning if I was to change that's another reason why I'm putting the const there because of this address. Because if I declare it without the const, what's going to happen is that since it's gonna take it. I'm passing by reference or by address. That means these parameters they'll point to the same variables as the ones that I'm passing. Meaning, if I was to change these variables, calls, rows, if I was to change it the inside the function, then it will also change and affect all the other ones that are all the variables that are passed, right? So basically, if, for example, let me make an example here. So if I have int x, right, and then I have a function here called print or update, let's call it update. It takes in some integer by reference, right? So let's call it that variable some value. And then you could just write it as a function prototype and then implement it underneath. That's fine. But here I'm going to do everything all at once to save time. So let's say inside the function, we change the value to be equals to 10. Since it's passed by reference, this variable over here will point to this exact same location as this variable. Because as I'm saying, pass it by reference, meaning whatever is passed, in this case, I'm going to pass this variable. That variable that's passed, go to where it's stored, its location, and copy its address, right? So that means they actually refer to the same thing. It's like basically when you have a friend, when you have Chomi, right? And Chomi sends you an address and you go visit Chomi at that address. Are you guys not in the same home? You are, right? So that means if you change something, it will affect Chomi too, because you guys are pointing to the same address, to the same location. So that's why if you don't want to change it or update it, you can still make the application small by passing it by reference. But if you don't want to change it, you can put a const there, which will actually prevent you from changing it. But it saves memory. There's this thing called memory. It's quite very important. By memory, it's like, for example, when you download, imagine, okay, let me show you let me explain why it's important, this address and putting that const there. You might be like, Marase, isn't this the same as just passing it by value? But why do I have to put const and address if at the end of the day it just simply means declaring it and passing it by value? What's the point? Why do I have to add address and const? Why all those extra steps? Because it saves memory. It basically when I was reading this, right, I remember, I think it was last year, they were explaining that if you pass by reference, it actually doesn't create a new variable. Basically, that means there's no memory allocated since they both point to the same location. So I'm not sure if that's entirely true, but from what I've read, that's what they've said. So if that's the case, that means I save memory. That means my application can become as small as possible. Remember, applications, what we're doing right now, right? In the future, when you're good enough to make Android applications, basically applications like Instagram or a calculator on your phone. Well, once you're good enough to do that, you realize that space is very important. That's why, for example, when you go to Google Play Store or Apple Store and you're trying to download an app, I guess some apps are very small, like 10 megabytes, 100 megabytes, and then some are like 2 gig, 10 gig, right? So all of that, those gigs and megabytes, if you don't you pass by reference, it actually becomes bigger and bigger and bigger. That's why we have to pass by reference. But in this case, I want to change it, right? So I want to set it to because to 10. Then now let me call the update function. So I'm gonna print the value X before updating, right? So before updating, and then print the value X, and then end the line. And then I'm going to update it by calling the update function. Remember, the update function is a void function. It doesn't return anything. So I just pass it like this. And then this will be after updating. Since it's passed by reference and there's no const, it would actually change it. Because this variable called value, it will point to the same address of whatever's passed. In this case, we passed X, so it will point to the same address as X. Before we do that, this will output an error. Here we're supposed to return if this, remember this creates, yeah, this was a perfect, this is a very good way of naming this function. It creates a game world. So that means you need to get back a game world because it creates a game world. So I'm gonna say game world because that's what the function should give you back since that's what it creates. And then it needs all these numbers in order to do that. So let's test the update function so that you see that there shouldn't be any error. Yeah, no error. Yeah. Do you see the magic? I actually changed it in the function, but all of a sudden X is now 10. How? Because you passed it by reference. That means you guys are in the same house. You're at the same address. So that means if you're at Chomi's place and you drink Chomi's cold drink, won't Chomi also be affected? Let's say you finish a cold drink. That means Chomi doesn't have a cold drink because you guys are occupying the same memory. So, or the same location. So how do you prevent that? How do you still make, how do you actually still make the application lightweight? Basically, you still pass by reference, but you don't want to change it. That's where you put in the keyword const, meaning it should remain constant, right? It shouldn't change, even though it's passed by address. So now if I run this, I should get 00. To be honest, it actually prevents you, see? It even prevents you from assigning. It will be like, Chief, what are you trying to do? There's const there. What magic are you trying to perform? So let's look at the logs. So that's why my code kind of looks weird. It doesn't look like the lecturer's code. And because I'm trying to be as direct as possible. You see, it tells you that this is you need to learn to read errors. This is a read only the reference variable. You see, it tells you that it's passed by reference, but it's read only, meaning you're only allowed to read it, not change it. So that's why I put the const there because I want to make my application lightweight, basically passing it by reference, but the values that I'm passing, I don't want to change them inside the function. So I hope that makes sense now. So I'm gonna, yeah, you can just watch the recording if you want to check this. I'm not gonna save this code. This was just an example, so I'm gonna undo that. So let's continue. So that's why I'm passing it like this. It might look insignificant right now, but to be honest, it helps a lot. It makes the application faster. So that's how I'm going to do it. So these are the what's provided as command line, and then the detectors are placed, blah blah. So every line after the first line, right? It actually describes the implementation of the function. We are not there yet, so we need to scroll down and go under simulation. Go to phase two. Basically, because the way I want to approach the question paper, right? If you've noticed, I start by creating all the functions that I needed, basically all the function prototypes. Then once I'm done creating all the function prototypes, I then implement all of them inside the CPP file. That's how I choose to approach it, and I feel like you should do the same. If you feel like you can't do the same, it's fine. You can create this function, copy it, and paste it inside CPP, implement, then try to code it inside main, testing one function at a time. You can also do that. That's allowed. Remember, it's up to you how you structure it or how you approach the question paper. And then simulation, the simulation runs only if there is a pathogen present in the system. So we need to actually do a simulation. Let's check what we're supposed to do. So we basically need a function called simulation or simulate, right? If there is no pathogen in the system, the user must only have two options, right? Okay, that means if there's no pathogen. So basically, a pathogen has not been placed. In this case, do you see that? Let me see. Yeah, at the start of the simulation, there will be no pathogen. Hey, 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 hey. Awanyiwa mo. It's going down here. A simulation, it doesn't play around. I'm saying 1 year for you guys. It's going down for you guys. I know. Me when I read the question, I'm at the point of when I look at the question, I have I immediately get the answer in my head. That's how experienced I am now. I can see how you're gonna implement this in my head. So I know the answer there. When the user introduces a pathogen, they must place it at an empty random location. You see, yeah. So that means the simulation function is gonna simulate. That means it should take in our reg world, right? Let's see if there isn't. Yeah. So it needs to take in, yeah, there's quite a lot, yeah, there's quite a lot of code inside this function. Because if there is no pathogen, we have to introduce it. And then when the user introduces introduces a pathogen, it must be placed in an empty location. Then we place it. So we check inside the simulation function, we need to check if a pathogen exists in our game, meaning in our 2D array. If it doesn't, then we introduce it. And then when the user, after we've introduced it, if that means there will now be a pathogen in the system. Then the user is given two more options, basically to continue the simulation or to quit, right? So that means this simulation is gonna take in let me see. Mm, Let me see. I'm thinking about functions. What functions should I create? Let me think. I'll just call it simulation or simulate. But the name just call it simulation because if I say simulate, to be honest, simulate is it's actually a better English word because remember functions, you must use verbs. So simulate, it's an action, but simulation, it's you remember how you name functions. You don't say creation. No, you say create world. So that's why I'm gonna say simulate instead of simulation. So this simulate function, it should be a void because there's nothing that it should return. I don't see what thing can it return. The user must have blah, blah, blah. So yeah, it should take in, let's see if there is. Okay, I'm thinking about the clever way of declaring the simulation function. Yeah, I'm thinking about a clever way of doing it. Let me think. The thing is, I have multiple solutions in my head. Which goes to show that there's no one right answer. You can answer it in any way you want to answer it. You, the programmer, must choose the simulation, oh, it's just similar words. There's simulation and stimulation. So you must choose the stimulation threshold value on your own and make it a constant in the header file. Oh, so that means our simulation function shouldn't take in any inputs. Okay, so far, let's check. Okay, I'll give you an opportunity to ask you a question. For each detector, if the Euclidean distance between the detector and the pathogen less than the simulation threshold, the detector is stimulated, which means it must be cloned. Yeah, 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 yeah. Wanyiwa mo. And this was the main paper. It wasn't a sub. It was a sick test. Ayala cooked for real. Hey, Mr. What is Dr. Tungo? I sets the paper. This guy, he doesn't play around. It must be cloned. So in the process of all that, you still have cloning. I get the code out to do that, but it's kind of a bit too much. Cloning a detector means you must create two new. Uh, and then you must place them within one block around. I want you. Yeah. Hey, yeah, this question paper was on steroids. Like, even for me, I have to think a bit. guessed, it shakes me a little bit. So imagine for you guys, how is it going to be? If a selected block already has a detector, there's no need to search for a new block. Just replace that detector. Hey, that's a lot of logic right there. But we'll get to that when we get there, right? Okay, update the detector population. After completing step one, remove N detectors that are farthest away from the pathogen to avoid overpopulating the system. Mm, mm. You, the programmer, must also choose your own value for N and make it a constant in the header file. Play around with the values and see how it affects the immune response. This is UG. This is ComSci at UG level. No wonder why they respect ComSci. If you have computer science degree from UG, they respect it in the industry because they know you guys work a lot. You get challenged. So yeah, there's quite a lot. Yeah, this question paper is speaking a lot. So for now, it didn't mention about in order to do the simulation, you take in some value from the user. It didn't talk about that. So that means I'll simply pass in a game mode. But since I want to update it, I'm gonna pass it by reference, right? Then I'm gonna call that, I'm gonna create it's a variable called rec world. Remember, we talked about record structures yesterday, so you should understand that this is game world is just a data type, and record is a variable of that type, of type game world. And since I want to change it, right, I'm not gonna put the const there. The const will be useful if I don't want to change it, right? So simulate, and we also need the print function, right? So void display my game world. So I'm gonna call it display game world, which takes in my game world, right? Remember, we want to save as much space as possible, so I'm gonna pass it by reference. And since this function only displays, that means it shouldn't change, or I shouldn't have the ability to change my game. So I'm gonna pass it by const reference. You can ask your question before I forget. Can you unmute and ask a question? Whoever raised their hand, can you ask your question?
Uh, I was wondering where can I get the thing that the question paper you're reading?
The question paper.
Yes.
They sent it in the group, most in the group chat that we have. Yeah, the my group chat. Someone sent it there. This question papers, I think.
Okay, okay, I'll check that. I'll check them.
If you can't find it, it's fine. I'll just zip it and send it in the group. Yeah, so let's continue. So it's up to you how you want to declare this function. What I could do, right? It's up to you. Remember, it's up to you how you solve the problem. What I'm thinking, right? I'm thinking of creating a Boolean that keeps track of whether a pathogen has been created or not. And since this Boolean is related, or it stores information that's related to my game world, I'm gonna put it inside the record structure. So I'm gonna say bool is should I say is what contains a pathogen. Also, I'm gonna say has pathogen, right? That's what I'm gonna call it. Basically, it stores whether this game world has a pathogen. It stores whether this game world has a pathogen or not. And then artist born, let's check. When the user introduces must be placed in a random location. Yeah, we're gonna place that. That's not a problem. If there is a pathogen present in the system, the user must only have two options. So we have continue and quit. So remember we need an enum for options, right? They're called options, right? Yeah. So these are called options. So we need constants for them. Let me see. Yeah, but why do we need constants? Remember, if you remember the game that we made in the previous the first game we made, right? I get it move up, move down, move left. That was like sort of like one of the options, right? That you can choose from. You can choose to move up, move down. You can also choose to quit. So we can create constants for that to just make our application, like friendly, like user friendly. We can have a quit constant and a continue constant, right? Something like that. And we can also have an introduce pathogen constant, right? Let me see, but then no, let me see if there's no pathogen. So case, okay, okay. Let me see. Yeah, introduce, we don't need it. I think the ones that we might use is continue and quit. I think those are the ones that we can use. Yeah, but it's not really important. I think it's fine. Let me not complicate it. It's fine. Let me not create the enum. But you could technically create an enum there. So let's see simulation. Yeah. And then after simulate function, it's fine. I won't create that enum. After simulate function, I need remember this creates the game mode, which actually allocates memory. So what do we need to do after allocating memory? We need to deallocate. It's like, for example, after using the plate, again, you wash it, so you clean, so that the next person is going to use it, the plate finds it clean, or you, when you want to use the same plate tomorrow, is going to find it clean, right? So we need to clean the memory once we are done using using the memory. So I'm going to have a void. I'm going to call it, since we created the game mode, we can now destroy our game mode. So since we're actually updating the game mode or actually making changes, we pass it by reference. And I'm not gonna put the const there because I actually want to change it. So record. Yeah, so this will be the structure that will follow from now on. I'll use this record structure and I'll always pass by const reference if I don't want to change it because I want to be as accurate as possible. Trust me, this is quite useful. I forgot to send you guys the link on the website. There's a free course where you can learn C++. So they give you more like a quiz right after each chapter. And after you've done with I think, for example, let's say you're done with for loops, there's also a question that you can, a code that you can write to ask you, print these numbers, for example. And it's free. And then you can also get a certificate once you're done. Then you post it on your LinkedIn. So I'll send you guys that link. I was too lazy to finish it because I didn't have time, but I'll also try to do it on my too. The links that I sent you, right? Most of the time I also do those same courses. So just take my advice when I give it to you. So let's talk about the constants that we need to create. If you look at the copies for detectors, right? Stimulation the threshold, the detector stimulated, it means that it can be cloned. Um, around the block, blah, blah, blah. Yeah, they said this should be a stimulation threshold value. I don't know whether it's an integer or what. I think it could be an integer. Stimulation threshold. So let's see. Yeah, they said if the pathogen is less, if the Euclidean distance between the detector or Euclidean distance. Remember, if you know physics and maths, distance actually has to be a double because it can be 2.5 kilometers, right? Something like that. So it has to be a double. So I actually have to make a double constant. And I'll make it, I honestly don't know. Let's say the constant is, let's see. And remember, did I talk about that? I think I did. I'm not sure. Or maybe it was last year. But I think I did talk about constants. So when you create a constant, right? Remember we use the keyword const if it's an integral constant. Basically, you use the integer type. And then if it's an expression, basically using things like curly braces or a double, because a double has a dot, right? Which is a special symbol. So we actually call that an expression, but then it's constant, meaning it doesn't change. So therefore, you're going to use the keyword const expression, EXPR. That EXPR part, right? It means it's an expression. So const expression, a double, and then we're going to have stimulation, threshold, right? And we know that it's going to be a double, so I'm going to make it 4.9. I don't know. I just chose the random, right? There's no reason why I'm choosing this number. It's just choosing random because they said you should choose the number. If you check here, they say the value on your own. You must choose the stimulation threshold value on your own. And then they said make it a constant. in the header file. They're so straightforward. It's very direct, this question, especially here, it was very direct. There's no way you cannot understand that. After completing step one, remove n detectors, meaning the specific number of detectors. And this value, you must also choose it on your own. Since it's a number, it's basically the number of detectors. For example, they can be 2 students, 3 students, 4 students. They can never be 4.5 students, right? Uh, unless, but let me not make that dark joke, but unless, yeah, but there's no such a thing as 4.5 people. It's 4 people or three, or it's always an integer. So I'm gonna use const int, and I'm gonna say n is equals to, let's say I'm gonna remove, let me choose 2. Let me not choose a very big number. Let me choose 2 for now. And then I fixed how it fixed the main system. Yeah, and then we are done with our header files. Yeah. Okay, not done. We need to include the header files that we're gonna use. So we're gonna use quite a lot. So I'm gonna print. So I'm gonna use input output stream. So IO stream. So IO stream. And then I'm gonna have some errors, right? You see there's errors. So I'm gonna call the exit function, which is part of the CSTD library, which is basically stands for C standard library, lib for library. And then I'm also gonna convert, oh, we're using command line arguments, my bad, totally forgot. We need to create a function that converts a string to an integer. So yeah, let's decide on that. We need a function that converts from a string to an integer, right? So I'll simply call it convert to integer, or you can say convert to int, right? Let's just make, let me actually make my code readable. Let me write it in full. The function should be called convert to int. Since it converts to an integer. Remember, we talked about this part over here that the parameters are the inputs. So what input am I taking in? I'm obviously taking in a string that I need to convert to an integer. So I'm going to take in a string, and it's part of the standard namespace. So I'll say it's just value, right? And since the string is part of is part of a header file, so I need to include the string header file. And then I need to include, what else do I need to include? Yeah, string stream. So it's S stream, because I'm gonna put the string inside the string stream and then take it out of the string stream and convert it to an integer. So since I'm converting to an integer, I'm gonna make sure I return an integer. So I'm gonna leave it like that, returns an integer. And yeah, you could remember we need to save memory. Let me also you do that. You see this value that I'm passing in, I'm not gonna change it, right? So I'm actually gonna pass it by reference so that it saves memory. But since I'm not gonna update it, I need to put const there. So const reference. Because like I said, I want to be as accurate as possible in my code from now on. Because obviously, guys, you're being trained to go to the industry. So you need to be ready for the industry. This is how they declare the parameters. And then what else do I need? Random generator, right? So C time. So hash include C time. And then I'm gonna use the standard namespace, but I'm gonna say using standard namespace only inside the CPP file, because that's where I actually use it a lot. I implement things. Inside this header file, you see I only use it here. So there's actually no need for me to say using namespace standard. So that's why I'm not doing that. So we have everything, I think. So let's copy these functions. And if you not look at how I'm doing look at the order, right? You need to follow the same structure so that you don't make mistakes. You see in the CVP file, I did put my namespace there. Then now I put the function implementations inside the namespace. You do your own things, it won't run. Then to write implementation, you replace all the semicolons with curly braces like this, so that you provide the implementation for that function. And then, yeah, this question paper is really challenging, Shem. I pray none of you guys gets paper B, or yeah, I think paper B is usually simulation. Yeah, it's simulation. I hope you don't get paper B. But apparently they say it's chosen randomly, but I've kind of noticed the pattern that if you don't have very high marks, in terms of practicals, you usually get the easier paper. I think so. And then if you have very high marks, like distinctions minimum on all of your practicals, you get the harder paper. Because me, all the papers that I've written for both informatics and comp sci, they're always paper B. Because I don't know, because my practicals are always very high, like 100, 98, all of them, all of the practicals, they're always high. So I'm starting to see a pattern, even though they say, no, we choose randomly. I doubt they choose randomly. So there are the functions, right? So let's create our game mode. So obviously this function needs to return a game mode. So therefore we need to declare a variable of type game mode inside here. So game world, um, game mode, I'm gonna call it rec world. And then at the end of the day, I need to give back a variable of type game mode. So I'm gonna say return which variable is of type game mode. It's rec world. So return rec world. Then now I can do the implementation. So here I'm going to initialize my game world, right? Basically set the value. But remember we have a record structure here. It is all these things. So for now, they are still empty. So we need to initialize them. And remember how we call them. We call using a dot. So I'm gonna start by setting my rows and columns. So record dot rows is equals to the rows that I'm getting from the user as an input. That's how C++ can tell the difference, because here you've stated that from this record structure, dot, meaning get the rows inside the record structure, and then initialize it to these rows. Then it knows, oh, any other rows is only this one. So that means you're taking that value and putting it inside of the rows inside of that record structure. And then record.calls is equals to columns, and then record dot number of detectors is equals to number of detectors. And then what else do we have? Record that has pathogen. So it starts, remember in the question paper, right? They say it starts. And how do you define the starting of a game? Basically, we initialized it, we created the game. That's the initial state. So they say that what is it? Yeah, and hey, these people are trying to make sure you pass in a way. They put it under initialization so that you know that that function that does the initialization, that's where this code should go. They told you that at the start of the simulation there will be no pathogen. So that means number one, I'm gonna create a variable code that has pathogen and initialize it to false, meaning false, it doesn't have a pathogen. And when I'm placing my characters, I will also not place the pathogen because they said it starts without the pathogen. So at least I don't have to worry about that. Initialize my game mode. So here I'm now going to allocate memory. Allocate memory. So remember we have our array called array world, right? So array world, that array is equals to new. I need to allocate it on the heap memory, right? So it's equals to new. Remember, it's a two-dimensional array of integers, right? So it's int, pointer, pointer, like this. So I'm gonna break it down so that you understand the record structures a bit more. That's why I'm starting this way. So to allocate memory, start by the outermost pointer. Remember, each pointer refers to a specific dimension. So we start by the outermost pointer. We replace that with square brackets. Then inside the square brackets, we specify how big that dimension should be. So the dimension should start this. We basically don't start from. We're gonna start with rows. It's up to you how you want to structure it. If you want to start with columns, that means you actually put columns there. But then that means all of your for loops, they always start with the columns loop. That's why it's very important to understand what you are writing. Don't just cram. But then this part over here can be replaced. Remember, we used type def. We said it is a new name. If you remember, if you go back up here, so that means everywhere where you see this, replace it with this. So I'm gonna copy this and then replace it here. Then it's still the same thing, but then it kind of reads better now. It's like you're saying allocate memory for that 1D array, and then I'll be left with another 1D, the one-dimensional array to allocate memory for. Then now I need, since remember it's up to it, the order is very important. you initialize it starting with rows. So that means the first loop will always be start going through the rows. So R is less than rows, R plus plus. And you might ask yourself, why am I not using the rows from the record structure? Well, that's a lot of work because I would have to always say record dot, and I still have access to these same rows. So I can just use them because at the end of the day, as you can see, they're equal. So either one that I can use anyone. And now let's allocate memory for all the rows. So I need to index. So pass R there because this variable R, it stores each row as I'm going through all of the rows. Then each row should be allocated. Remember, we said it's int pointer pointer, right? But since we've already allocated for this first pointer for that dimension, so we've allocated, we're done with that. So I'm gonna remove it. Now I'm left with this. So I need to replace the star or that pointer with square brackets and the size. The size should be of size columns. You might ask yourself, Mara, why don't we put another name there? There's no type def for int, right? There's no another name. There's nothing like this here. Type def int. There's nothing like that here. We haven't declared that. We don't need it. So that's why I'm gonna leave it as int. Then you could, to be honest, you could just leave this as it is and create another for loop at the bottom. That's fine. But to save time, I don't want to do this, right? Because remember, after you've allocated the memory, you need to go through each coordinate and initialize it to an empty space because it always starts with an empty space. Yeah, it always starts with an empty space. So you could do this, right? Divide the code, but you're gonna see that it's actually pretty redundant. So you're gonna say is equals to go through the rows first because why? You started by initializing it to the rows. That's why you in my code, I start going through the rows first. And then I go through all of the columns for each row. My bad, int C is equals to 0. C is less than calls, C plus plus. But then do you see a pattern here? This looks exactly the same as this. So that means I'm only left with this for loop. So I might as well just put this for loop, the for columns for loop inside here. Basically, kill two birds with one stone. I allocate while I'm allocating, I also initialize it in empty space. So that's why I don't see the need for doing this because you're gonna waste time. So don't waste time. So I'm gonna go back here and then I just simply go through all the columns. So int C is equals to 0. C is less than column C plus plus, right? And then initialize every game character to an empty space. Initialize every coordinate to an empty space. So every coordinate is inside the array. So I have to go to my array. But then since it's two-dimensional, I need to specify, use two numbers to point to a specific coordinate. So I need to pass in R and C, row and column. And then I say is equals to an empty space. Remember, we have a constant for that. So that's why I'm initializing to this. But then remember, this just simply sets it to all zeros. But then I've given it a name, right? So I don't have to pass 0. I pass it a name instead of 0 so that it reads like English. You see, is equals to empty space instead of seeing zeros. Because in the future, when you look at your code and you're trying to read it, you might get confused, even if you're the one who wrote it. That's why sometimes we try to make sure that it's as readable as readable as much as possible. It needs to be readable because when you look at it, even yourself in the future, you need to be able to understand what you were writing there. So now let's look at what's going on here. So we need to what? Detectors are placed randomly throughout the array. So they need to be placed in the array and it's under initialization. So we actually need to place our detectors. A detector cannot be placed on top of another detector. So it's simple. We basically implement the place feature function. So let's do that. Since if you notice, let me zoom out a bit. The thing is, I'm zoomed in quite a lot so that you can read the code. You see that I'm still within the namespace, right? There it is. I'm in the namespace, and I need a helper method. We call these helper methods when you get to ComSci 1B. They're called helper methods because basically they're meant to help you. And if you notice, remember, C++ reads from top to bottom. So since I want to place the feature, I want to call the place feature function inside here. I can't declare it after the create word. So I can't come here and say void place feature. No, I can't do that. It's gonna crash because it reads from top to bottom. So I need to actually declare the place feature here at the top. So I'm gonna go here to here at the top, and then I'm gonna create a function called place feature. So void place feature. Right, so place feature, we need to place it into our game mode. So therefore I need to pass in a game mode. So since we are placing the word place, it means to change, right? That means I need to go to a location, look for an empty space, change that empty space to a detector. So I'm updating my game mode. So I need to pass it by reference. And then right world, comma. We also need to pass in the feature that we want to place. So we need to pass in two things, the feature that we want to place and the number of times we want to place that feature. So we need two numbers. So I need const int, and they're both, and remember something, right? You might be like, yeah, why don't shouldn't I just say shouldn't I just pass it as an integer, the feature? We can't pass it anymore because I have an enum that represents a feature, you see? It's called game feature, which represents my feature. So I'll actually make the function pass in a game feature, something of type game feature. So I'm going to say const game feature by reference, but it's const because I don't want to change it inside the function. I just want to take it as it is. Basically, when you say const reference, right? Yeah, you're technically passing it by value. That's what you're trying to achieve. But passing it by value, it actually copies the value to a different variable. But if you pass it by address, it doesn't copy the value at all. So you save that space of copying and transferring the values because the value might be too big. So, or yeah, yeah, it's quite important to pass it by const reference. So I'm gonna call the variable feature and then call my text in the number of features that you want to place. So const int by reference number of features, right? So I'm going to call it number of features, and it shouldn't also be changed. So it's going to be constant reference. Then inside of my game mode, game place feature function, right? Okay, time is up, but let me just quickly implement this. I will continue after I'm done implementing the place feature. So, or maybe I should start at 9 with the other students. I think I can, nah, let me not, because the thing is it breaks thin, water leaves, and I still need to cook. So let me not push it. Let me just finish this function, then we'll end the session. So we have a number of features that we need to place. So I actually need to, since I'm going to place more than one feature, I'm going to actually create a for loop. And remember, we said that a for loop is used when you know how many times you're going to loop, basically when you're counting. So for example, I have number of features I need to count. So int, I'm going to call it n is equals to 0. N is less than number of features and n plus plus. Then inside of this function, that's when I can start placing. So in order to place, right, I need to actually generate a random row and a random column. Well, I think we won't have time to do everything. Let me just, I will continue tomorrow. Let's not push it. So, yeah, tomorrow is Sunday, right? So I think we should have sessions during the day. I don't know. The thing is today I got caught up with something. I think in the morning we should have a session. We should tomorrow morning. I'll tell you the exact time in the group so that we kind of speed up the process of doing past papers. So I need to generate a random integer. So I need a function that does that. So int, I'm gonna call it random int, right? But no, it shouldn't. It should use a verb. So it's fine. I'll call it generate rand int, right? Basically generate a random integer. Okay, it's fine. You can write it in full, like generate random integer. That's fine, but that's too long. But it's fine because I want this code to be readable. Then this variable, these values that I'm passing, I'm not going to change it. So I'm going to pass them by constant reference. So I need to pass in a starting point or int lower, but it's up to you how you want to name it. So I'm gonna call it the starting point, because remember, when you generate a random number, you need to pass in the range, which is the starting and the stopping. So I'm gonna actually declare them as int start and stop. Pass by reference, I'm gonna call it stop. And then I need to generate a range. We talked about how this function works, so I'm not gonna touch on that. So it's the stopping point minus the starting point plus a 1. That's how you find the actual range. And then you return a random integer by calling the rand function, and then you divide it by the range, so that basically you force that number to be within that specific range. That's why we divide by the range. But we actually divide and find a remainder, not just division, but it's modulus, and then mod it by range. And if you leave it like this, it actually stops at 0, and it stops at a number -1. It's less than the range, right? Basically, it stops at the number before the range. So if remember the range, it means in a way you can say the range. It represents how many numbers should be there. For example, if you have 1 to 4, that means your range is 4 minus 1, which is 3, plus 1, which is 4. So that means you should generate 4 random numbers, which is true, because 1 to 4, it's 1, 2, 3, 4, which is 4 numbers. But then the range function, what it does, right? If you mod it by 4, what it does, it actually generates numbers from 0 to 3, if I'm not mistaken. It really starts at 0. So in order for, no, I think it's, yeah, I think 0 to 3, if I'm not mistaken. 0 to 3. Yeah, 0 to 3. Yeah, that's true. Exactly. 0 to 3. So how can we do, well, what can we do in order to change this to be in the right range? Basically 1 to 4. We simply add back 1, which is our lower bound, or our starting point. So that means by 1, that means it no longer starts at 0, now starts at 1. It no longer starts at 3, it starts at 4. It stops at 4. So it's now 1, 2, 4. I hope I'm making sense. So this will be plus start. And then that's the random function. And then we gonna need to use it here. But then it's fine, we'll continue tomorrow. Yeah, because I need to go to ComSci to A students now. So that's it for today's session. We'll see you tomorrow. I'll tell you what time we're gonna have the session in the morning.